Right, folks, one of the most common things that we come across in secondary school maths is Pythagoras' theorem. And Pythagoras' theorem, in a nutshell, is to do with right angle triangles. And the theorem basically says that if we have side lengths A, B and C, where C is the longest side of the triangle, also known as the hypotenuse of this right angle triangle, A squared plus B squared equals C squared. And one of the things that Pythagoras himself strove for was to find whole number solutions for this. And those whole number solutions are called Pythagorean triples. Now there's not many of them compared to how many that aren't whole numbers, but one that's commonly known is that 3 squared plus 4 squared is equal to 5 squared, or 9 plus 16 equals 25, which is true. So 3, 4, 5 is a common Pythagorean triple. Now one of the things I'd like you to notice within that Pythagorean triple is that these two here add up to 9, which is 3 squared. And that can be a common pattern amongst Pythagorean triples. If we can add two numbers together, two consecutive numbers together, to get a square number, then we can create a Pythagorean triple. So for example, if I pick 12 and 13, 12 add 13 is 25, and that is 5 squared. So a common Pythagorean triple would be 12, 13 and 5, and that is because 5 squared plus 12 squared equals 13 squared, or 25 plus 144 is equal to 169. True. So if we were to pick, let's go through the odd numbered square numbers. So we've got 9, we've got 25. The next odd number square number would be 49. And to pick the consecutive numbers that add together to give that would be 24 and 25. And this is 7 squared. So my Pythagorean triple here would be 24, 25 and 7, and that is because 7 squared plus 24 squared is equal to 25 squared. And I'll let you check that out. So 49, next odd number square number is 81. That is 40 and 41, the consecutive numbers that add together to give to it. That is 9 squared. So 9, 40, 41 is the Pythagorean triple. Now, in order to create some more, what we can do is we can start to multiply these. So if we've got 3, 4, 5, if I double all those numbers and get 6, 8, 10, is that a Pythagorean triple? Does 6 squared plus 8 squared equal 10 squared? Or 36 plus 64 indeed does make 100. So that works. So start from this base, I can times by 3, so I could have 9, 12, 15, or I could have 12, 16, 20. All those are all Pythagorean triples. So if you were a teacher, for example, and you were setting up questions for children to do on Pythagoras, you could set questions where they had to find a third side, or the long side, and if you set 12 and 16, you know that it would come out as a nice answer and they would be really happy. So this idea of multiplying works with all of them. So if we look at the 5, 12, 13 triple, you could have 10, 24, 26. You could even have 50, 120 and 130. That is a Pythagorean triple. And if you were looking at the 7, 24, 25 triple, if I say wanted to multiply them both by 8, just to pick the number, 56, 200, 192, I think you should find that 56 squared plus 192 squared equals 200 squared. So some nice ways of looking at it, and really just to make you aware what Pythagorean triples are. So that where Pythagoras' theorem works for whole numbers, generally it doesn't work for whole numbers, but there are some nice examples of where it does do. And so you can make your own little values by, first of all, thinking about these consecutive numbers, and secondly by then multiplying up to give you some nice questions to do should you need to. Okay, hope you enjoyed that. I'll see you soon. Thank you.